Hey guys, welcome back. Today we are going to discuss about the very important topic in SQL, which is join. A join is a query that access the rows from two or more tables. A join operation is essential to retrieve the data from two or more tables, and the tables involved in the join operations must be joined on a common key fields from both the tables. As mentioned here, the select list of the query can select any column from any of these tables which are part of our join operation. But if any two of these tables have a same name column, then we must need to qualify those columns with table names to avoid the ambiguity issue. Let's look at the types of joins. So basically we have four kind of joins available in SQL, and they are inner join. It is sometimes called as natural join or equi join. Then we have outer join, and under outer join we have three joins, namely left outer join, right outer join, and full outer join. Let's look at them one by one and try to understand their use cases. Let's talk about the first join, which is inner join. An inner join returns the matching rows from both the tables. Let's look at the syntax of inner join. We can use select column names from table A, column names from table B. Then we need to say from keyword and then the first table name. We can specify the alias also. In this case, we have mentioned it as A. Then we need to use a keyword called inner join, and then we need to specify the second table name which we are using as part of that join operation. We can also provide an alias to the second table like mentioned here as B, and then we need to use a keyword on, and then we need to take the common keys from both the tables. We must have the common key field in both the tables which are participating in the join operation. Now let's do some practical examples to use inner join. So here we are in our SQL developer. Here we will be using two tables, namely EMP and DEPT. Okay, we call them as employee and department tables also. So let's first see what is there in employee table and what data is there under department table. So we have 14 records in our employee table with 8 columns. Now let's see what is there in department table. So we have 3 columns. If you notice, the department number column is a common column between employee and department table. So let's use this common column and get the fields or the column names from both the tables. So let's get employee ID, employee name, job and salary from our employee call table and department name from our department table. So for this, I have mentioned all the column names in the select clause, and then I have taken both the tables in from clause saying from employee inner join with the second table department on a common keyword or a common column department number. I have also sorted the data based on department number. So let's go ahead and run this query. So if you notice here, we have got 11 records which are matching between both the tables. Let's include department number column also here. So if you notice, this department number column is available in employee table as well as in department table. So when we use this department number column in our select clause, Oracle will get confused from which table I have to show the data for this column. So if you run this query for now, it will throw us an error. Column ambiguously defined. Okay. To overcome this issue, we should always qualify these kind of common columns which are available in both the tables with either table name or with alias. So for now, let's use the alias B to get the data for this department number column from our department table. So let's run this query, and if you notice here, we have got the department number column also in the output. It is always a good practice to use the alias name when we are fetching the column from any of the table being involved in our join operation. Let's look at the next join, which is left outer join. So left outer join returns all the data from our left table and only matching data from our right hand side table. So here is the syntax of left outer join. We can select our columns from table 1 or table 2 as per our choice. Then we can mention those tables in the from clause. From table 1 alias as A, and then we can use the keyword left outer join, and we can specify the second table name after this keyword. After this, we need to specify on keyword, and we need to provide the common columns from both the tables for the comparison. Please notice whichever the table is being used before left outer join keyword is called left table, and whichever the table is being used after left outer join keyword is called a right table. So let's go ahead and see some examples of using left outer join. Here we have created a query to perform the left outer join between our employee table and the department table. This time I have qualified all the columns from both the tables along with their alias. So if you notice here, the employee ID column is from table employee. Employee name column is also from employee. Then we have job, salary, and department number. So we are pulling these 5 columns from our employee table, whereas we are pulling just one column from our department table. And the common key between these two tables are department number. So let's go ahead and run this query and see what output we are getting. So if you see here in the employee table, we had total 14 records, and this employee table is being used as a left table, and hence we have got all the records from employee table, whereas we are getting the null values for the department names which are not available in our department table. So department number 10 is not available in our department table, and hence we are getting the null value for these department names. The next we have right outer join. This returns all the data from our right table along with the matching record from left table. If there is no match between these two tables, it gives null for the left hand table column values. So here's the syntax. We just need to change the keyword from left outer join to right outer join. Rest of the syntax remains same. We can qualify the columns using the alias from any of the table which are being used in the join operation based on a common column which is being used on clause. Let's look at the examples of right outer join also with the same tables employee and department. So here we have a query to perform right outer join between employee and department tables. To do so, I have taken these 3 columns or 4 columns from our employee table, and these 2 columns, department number and department name, from our department table. Notice here, department table is a right table in this query and employee table is our left table. And again, they are being joined based on a common key, which is department number. So let's go ahead and run this query. So we have got 12 records in the output. So we have 11 records which are matching between both the tables, whereas there is one record in our department table with department number 40 for which the data is not available in our employee table, and hence we have got the data from our right table, and since there is no match of that data in the left table, we have got nulls for those columns which are coming from our left table. I hope this is clear to you. Now let's move on to the next join, which is full outer join. The full outer join returns all the records from both the tables, and if there is no match between any of the columns, it returns nulls. So the syntax remains same. Instead of left outer join or right outer join, we can just use the keyword full outer join to perform full outer join operation. Let's look at some practical examples for the full outer join also to understand more about this. So here we have the query to perform full outer join between employee and department tables. It is exactly same query which we have seen in the previous join. We have just changed the keyword from right outer join to full outer join. Let's run this query and see the result. So if you notice here, we have got all 14 records, or in fact 15 records, out of which 11 records are matching, whereas we have data for department number 10 in our employee table, and hence we are getting that data, but the data for department number 10 is not available in department table, and hence we are getting the null values for those 2 columns which are coming from our department table. Similarly, we have the data for department number 40 in our department table, but we do not have the data for department number 40 in our employee table, and hence we are getting the data for the department table columns but not for the columns which are coming from employee table. So with this we have covered all 4 kind of joins. That's it for today. We'll see you in the next one. Thank you.